You gave an AI a folder full of files it has never seen before. No category list, no instructions, just files. And you asked it to figure out how to organize them on its own. This is the build session. 11 test files, 1 Python script, and I am going to walk you through every step. Here is the build order we agreed on before anything was written. Step 1. Write a Python script that reads the files and creates its own category list using a local AI model running on your machine. Step 2. Run it against the 11 test files and see what happens. Step 3. Fix what breaks. Step 4. Run it again clean and verify the output. Then we commit the code to GitHub and show you what the folder looks like when it is done. The script is written. Here is what it does. The old version had 13 IT document categories hard-coded into it: network documentation, security policy, incident report. The problem with that approach, it does not matter what is actually in your files. The categories were decided before the script ever ran. The new version has 0 hard-coded categories. Instead, it works in 3 phases. Phase 1 is discovery. The script reads a sample from each file and sends them all to Ollama at once. Then it asks, based on what you just read, what categories belong here. Ollama decides from the content, not from a preset list. Phase 2 is classification. Every file gets matched to one of those discovered categories. Each match comes back with a confidence score from 0 to 100. We ran it. It broke on file 4. Here's exactly what happened. Ollama returned valid JSON on the first 3 files. On file 4, it wrapped the JSON object inside another JSON string, an extra layer of encoding the script was not expecting. When the code tried to call get on what it thought was a dictionary, it was actually holding a string. Python threw an attribute error and stopped. Files also came back with 0 confidence. Same root cause. The parse partially worked, but the confidence value did not come through correctly. One file moved correctly. 3 others either crashed or landed wrong. This is exactly why you run a test before you touch 350 real files. The script needs to handle whatever Ollama sends back, not just the clean version. The fix was 3 lines. Before parsing the JSON, the script now searches for the first open curly brace and the last close curly brace and extracts just that portion. This strips any explanation text Ollama added around the JSON object. Then it checks whether the result of parsing is a string or a dictionary. If Ollama double encoded it, the result will still be a string. The script parses it a second time and gets the dictionary it expected. That handles both failure cases in one pass. The test files were reset. All 11 moved back to the root folder. Clean slate, ready for a second run. Clean run. All 11 files, no errors. Ollama discovered 9 categories from the content: tech news, job listings, Bitcoin analysis, AI development, social media, career advice, security, business growth, and programming. It built that list by reading the files. Nobody told it what to expect. 8 files moved automatically. The highest confidence scores were 100 out of 100 on 3 job listings files. That is Ollama with no uncertainty at all. 1 file landed in needs human review. Confidence was below the threshold, so the script parked it rather than guessing. 2 files went to the junk drawer. Ollama created the categories and still could not match them to anything it had named. The folder structure built itself. Open the test directory and there it is, organized, labeled, ready. Here is what this build proves. You do not need to know what categories your files belong in before you start. The system reads the content and decides. You do not need to approve every file move. The system handles the confident ones on its own. And you do not lose visibility on the edge cases. They go into clearly labeled folders that are waiting for you when you are ready. That is the core idea behind this project. AI handles what it is sure about. It flags what it is not. You stay in control without having to babysit every decision. This was 11 files as a proof of concept. The code is committed to GitHub. It works. In the next video, we run the same script against 350 real unlabeled files and find out if what we built today holds up at scale. Link to the GitHub repo is in the description. Follow along and build it yourself.